Okay, hello everyone. Today our topic is about other parameters in the circuit, okay? So let's move into the first part is about electrical energy and power. So first we are discussing about power. So maybe many times you are using electricity devices, right? And you'll find that here is a power value on it, right? Like if you are using your phone, maybe the power is 60 watt, right? Maybe you're charging your iPhone, it will give you a value that is like 45 watt, like 60 watt, like 100 watt, like this kind of word, right? And maybe you're using your lamp in your room. Maybe here you like fix a lamp on the floor, and you'll find that, oh, here's the lamp is also a value under its like lamp, right? It will give the number for you. So power just means like how the energy consumed for per second or per minute, right? So this is just a value. So if electrical device is needs very big power, that means it needs a lot of electricity when using it, right? So here we're just using this way to determine what is power. So power we can say is energy transfer over time taken. Okay, so circuits you can find here. Like we have a battery, it is 5 voltage, and it supplies energy per second. So that means that it gives 5 voltage and for 1 ampere like current on it, right? And then maybe we can say, oh, the total power here is like 5 voltage times 1 ampere equals to 5 watt. Okay, this is for its power. I think it's not very difficult for you, right? Okay, so this is for the electrical energy and power, and this is basically based on power. Okay, and maybe you can find in your daily life we have different devices, like we have a like bowling kettle, and here is 2,400 watt, right? Maybe here's a lamp, it is 11 watt, and maybe a TV, a very old version TV, it is 50 watt. Okay, so different devices need different kinds of energy and power. Okay, so power is just followed when they're out of the factory, they're just designed at like this power. Okay. Okay, so please remember the formula is very easy. Power equals to voltage times current. Okay, UP equals to E times I. It's not very difficult, right? Okay, and here's an exercise. Like example in the circuit, maybe in this figure, and find the power of the battery and each of the lamps. Okay. So for this problem, maybe here you can find this is 12 voltage, right? And you can find the current here is 2 ampere, and maybe the first lamp is very big. You can find the size is very big, right? So maybe it takes a lot of a lot of voltage or potential difference right here. The potential difference here equals to 8 voltage, and here potential difference equals to 4 voltage. So for the first lamp above, we can say here the power equals to 8 voltage times the current is 2 ampere equals to 16 watt. Okay, this is the power. And another lamp is here, and we can say power here equals voltage times current is 2 ampere equals to 8 watt. Okay, this is for the second lamp, it is 8 watt. So first lamp is 16 watt, second lamp is 8 watt. Maybe we can say, oh, for total power right here is 16 watt plus 8 watt is 24 watt, right? So we can say, oh, this is the total power of the lamp. Okay. So this is the first example to let you understand how to use the formula P equals to U times I. Not very difficult, right? Okay. So next we'll discuss about the energy. So we said, okay, the power means the energy transfer per time taken, right? So if you're just calculating the energy, it equals to the power times time taken, right? It's just here. So maybe here the formula is very difficult. It's energy E. Sometimes we said work equals to U times I. This is power, right? Times time taken. So it's like this formula. Not very difficult, right? So how to use it? There's also another example. Like here, a 12 voltage water heater takes a current of 2 ampere. If it is switched on for 3 seconds, how much thermal energy does it produce? Okay. So for here, this problem, I think is not very difficult for you if you're just using the formula that here, work equals to UIT, right? Means the potential difference on the devices times the current of the devices times the time taken. So for the first lamp, you can set here, that is 8 voltage times I, current is 2 ampere, time taken is 3 seconds, right? So we can say, oh, here is 48 watt, oh, sorry, 48 joule, right? Because energy student is a joule, right? It's 48 joule. For second lamp, we can say, oh, here is 8 voltage times 2 ampere times, oh, sorry, 4 voltage. Sorry, I'm wrong. 4 voltage times 2 ampere times 3 seconds, right? So here is like 24 joule, okay? This is for the second example like here. So I guess this class is just based on how to calculate P power and how to calculate energy. Not very difficult for you. Okay. So this is our lesson today. Okay. See you next time. Bye.